A very good morning, students. Today we are going to start a new chapter, that is inverse trigonometrical functions. So let us begin our class. In lower classes, you might have learned about trigonometrical ratios. What are the trigonometrical ratios? Sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta. So these are called trigonometrical ratios. Also, you might have learned some standard values of these trigonometrical ratios. For example, 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. These are standard values which you are already familiar with. But now in this chapter we are not interested in trigonometrical ratios, but here we are interested in inverse trigonometrical ratios, or you can say inverse trigonometrical functions. So here instead of sine theta, you have sine inverse x. Remember, this is inverse trigonometrical ratio, so you have to pronounce like sine inverse x. And here cos inverse x. This is tan inverse x. This is cosec inverse x, sec inverse x, and cot inverse x. Now, remember one very important note. We know that sine square theta can be written as sine theta whole square. If you write like this, then this is correct. But sine inverse x cannot be written as sine x whole inverse. This is totally incorrect, because remember, this is not power but it is a function. Okay, it is a function. Sine inverse, it is a function, so you cannot write like this. So, and similar with other case also. Okay, now let us try to clear what is the relation between trigonometrical functions and inverse trigonometrical functions. Okay, if someone give you a question, if someone asked you what is the value of sine 30 degree, so you can easily answer it. So what's the value of sine 30 degree? Half. But instead of asking this question, if someone asked you which value of sine, so question, which value of sine gives half. So you are not able to answer this question because you are not familiar with inverse function. But since our question is which value of sine gives half, so this question can be mathematically represented as sine of which value gives half. Okay, sine of which value gives half. Since we already know that sine of 30 degree is equal to half, if you do like this, sine 30 degree is equal to half, then by comparing these two, you can easily say that sine, okay, which value of sine gives half? The value 30 degree of sine gives half. So this is the very question which leads to the foundation of inverse trigonometrical functions. So here sine of here which value of sine gives half. So here our answer is sine 30 degree gives half. So this question can also be represented mathematically as sine inverse half is equal to what? So this is the actual mathematical representation of this question, which value of sine gives half. Okay, so here since we know that 30 degree, sine 30 degree gives half, so here you can easily write 30 degree. So sine inverse half is equal to 30 degree. Okay, from this example you got, if sine 30 degree is equal to half, then we can say that sine inverse half is equal to 30 degree. Okay. So in general, if the value of sine theta is equal to x, here I am replacing theta 30 degree by theta and half by x. Okay. So if sine theta is equal to x, then we can say that sine inverse x is equal to theta. So this is the relation between trigonometrical function and inverse trigonometrical function. So this is our first formula. So our formula number 1, if sine theta is equal to x, then we can say that sine inverse of x is equal to theta. Now similarly, second formula, if cos theta is equal to x, then it implies cos inverse of x is equal to theta. Third formula, if cosec theta is equal to x, then cosec inverse of x is equal to theta. Number 4, if sec theta is equal to x, which implies sec inverse of x is equal to theta. Formula number 5, if tan theta is equal to x, then tan inverse x is equal to theta. If cot theta is equal to x, then cot inverse x is equal to theta. So these are the basic 6 formulas which is the relation between trigonometrical functions and inverse trigonometrical functions.